Hi everyone, it's Mrs. Griffin with the Unit 6 Lesson 8 video, where we're going to be talking about how to use trigonometry with word problems. So please do the opening exercise on your own and we'll go on to example 1. In example 1, the pitch of a roof of a home is expressed as a ratio of vertical rise to horizontal run, where the run has a length of 12 units. So if we think about that as slope, basically we're doing rise over run. The run is the horizontal distance. So if we're talking about how much a slope is pitched, or a roof is pitched rather, the run part is 12. If a given roof design includes an angle of elevation of 22.5 degrees, so that would be the angle down in here, elevating upward, and the roof spans 36 feet as shown in the diagram, determine the pitch of the roof. Then determine the distance along one of the two slope surfaces of the roof to the nearest tenth. So what we're trying to figure out is what the rise over run is for this roof. So in other words, we need to find the vertical distance in order to answer that question. So we are going to be using trigonometry because we have an angle and sides. So across from that angle is the opposite. Across from the 90 would be the hypotenuse, and this one is blank. And then that would mean that 12 is the adjacent. So in order to figure that out, we are going to have to apply SOHCAHTOA. So if I go to SOHCAHTOA, I want to pick the function that does not include hypotenuse, which would mean that I'm using tangent. So if I do tangent of the angle, which is 22.5, it would equal the opposite over the adjacent, and I would cross multiply. So 1 times x is x, and that would equal 12 times tangent of 22.5. Now, when I go to put that in my calculator, remember you need to be in degree mode. So go down to degree, highlight it and hit enter, and then you can clear it and use it. And we're doing 12 times tangent of 22.5, which would be 4.97, etc. Okay, but since that has to be rounded and they don't tell us to, you can leave it in this form. This is the pitch. Okay. Next, we also have to figure out one of the slope surfaces of the roof to the nearest tenth. So that would be this. If you look at this picture now, I'm going to separate it into 2 triangles. Okay, and since the roof would be the same on both sides, that 36 is going to be broken up into 2 18s. And so I now have this angle, the 18 in this one is the adjacent, and the y is the hypotenuse across from the right angle. So adjacent and hypotenuse is cosine. So cosine for 22.5 is equal to the adjacent over the hypotenuse. We're going to cross multiply and do y times cosine of 22.5 equals 18, and then since y is not isolated yet, it's not by itself, I need to divide by the cosine 22.5 on both sides. And then y would be 18 divided by the cosine of 22.5, and that's 19.48 to the nearest tenth would be 19.5 feet. Okay, number 12. Solving a right triangle means using the given information to find all the angles and side lengths of the triangle. We are going to be using arc sine and arc cosine along with the given information to solve a triangle. These are other ways of saying inverse, sine -1 and cosine -1. That's what those mean. Okay, so use those along with the given information to solve right triangle ABC. It tells me the hypotenuse is AB, so that has to be here, which means that my right angle has to be C. That's 15. AC is 12. So I have lots of ways I can do this. If I want to find the missing side, CB, I can use Pythagorean theorem, and I'm going to do that because I don't currently have any angles. And so when I go to find that, I'm going to find that the missing side is 9. So BC is 9. Next, I want to find the angles. So I'm going to start with angle A. If I'm using angle A, then I can use any of the 3 values. I'm going to use the ones they gave me. So this would be the adjacent, and this would be the hypotenuse. And I'm going to avoid using the 9 just in case I was wrong somehow. Adjacent and hypotenuse is cosine. So cosine for angle A that I'm looking for, remember that is adjacent over hypotenuse, 12 over 15. Since I'm looking for an angle, I'm going to do the -1 on both sides for cosine. And A will equal the inverse cosine, or arc cosine, of 12/15. And it does say to the nearest degree. So cosine -1 means I have to hit second cosine. 12/15 would be 36.86, so 37 degrees. Okay. And then B, I have a few options. I can use arc sine to find B. If I do that, now that I'm using B, the 12 is the opposite, and 15 is the hypotenuse. So I would have to do sine of B equals 12 over 15. And then I can use the arc sine, or the inverse sine, on both sides to figure it out that way. So second sine, 12/15 gets me 53.1, which is about 53 degrees. But also keep in mind that this was a triangle, so it had to add up to 180. So once I knew the 90 and the 37, I could find the 53 by using 180. All right, number 3. The sides of a rectangle are 25 centimeters and 8 centimeters. So I'm going to draw this so that this is the 25 and this is the 8 because it looks better. What is the measure to the nearest degree of the angle formed by the short side and the diagonal? So I'm going to draw one diagonal in there. The angle formed by the shorter of the two and the diagonal. So they want me to find this angle here. That's the angle I'm looking for. That's my theta. I'm going to use this right triangle, where that's the right angle, and I'm going to label. From this angle, the 25 would be the opposite. This one, which is blank, would be the hypotenuse, and this one, the 8, would be the adjacent. So opposite and adjacent is tangent. So tangent for theta equals the opposite, which is the 25, over the adjacent, which is the 8. Since I'm looking for an angle, I'm going to do the inverse on both sides. Remember, you only use the inverse for finding angles. So we're doing the inverse tangent of 25 divided by 8. And it does say to the nearest degree. So when I do inverse tangent of 25 divided by 8, second tan 25 divided by 8, I would get 72.255. To the nearest degree, that would be 72 degrees. Okay, number 4. A 16-foot ladder leans against a wall. So here's my wall, here's the ground, here's the ladder. If you need to draw it so that it actually looks more like a ladder, that might help. The foot of the ladder is 7 feet from the wall. That means that this distance is 7 between the foot of the ladder and the wall. Find the vertical distance from the ground to the point where the top of the ladder reaches. So we are looking for this. Determine the measure of the angle formed by the ladder and the ground. That would be this angle here. This is theta. So the only other number I have is that the ladder was 16 feet long. So I'm going to put that in there. So we have two things to find. We have to find the missing side and we have to find the missing angle. So to find the missing side, you can do Pythagorean theorem. That's still allowed. And it's probably better because we're going to have to round when we go to find the angle anyway. So x squared plus 49 is equal to 16 squared, which is 256. And when you subtract 49 from both sides, you get 207. And then you're going to square root both sides. And it does say to round the distance to the nearest 10. So the square root of 207 is 14.38749, etc. So to the nearest tenth, that would be 14.4 feet. Okay, and then the angle, if we're looking for theta, let's not use that because that got rounded. Let's use the 7, which is the adjacent, and the 16, which is the hypotenuse. Adjacent and hypotenuse is cosine. So cosine for theta equals adjacent over hypotenuse. And then since we're looking for an angle, we do the inverse. Again, inverse is only for finding angles. And so we will do second cosine of 7/16. Second cosine of 7/16 is 64. All right. Finally, number 5, 3 city streets form a right triangle. Main Street and State Street are perpendicular, so this will be Main and this will be State, since those are forming the right angle. Laura Street and State Street, so this third one has to be Laura Street, intersect at a 50-degree angle, so where they meet is 50 degrees. The distance along Laura Street between State Street and Main Street, this distance is 0.8 of a mile, so this is 0.8. Laura Street is closed for that 0.8 mile between Main Street and State Street, so that means we can't use that segment. Approximately how far to the nearest 10th would someone have to travel to get around the festival? So if we were starting here, normally we would go to this corner right along Laura Street, the 0.8, but we can't. We have to go this distance and then this distance to avoid it. That's the detour, the long cut. And that means I need to know how long this is, and I need to know how long this is. And I'm going to compare that to the 0.8 it would have taken the direct route. So I'm going to start by finding x. So the x is the adjacent to the 50, and 0.8 is the hypotenuse. Adjacent and hypotenuse is cosine. I know the angle is 50. X is the adjacent, 0.8 is the hypotenuse, and I'm going to cross multiply. So x equals 0.8 times cosine 50. I'm going to leave that as is so I don't round it yet. To find y now, I'm going to do the same thing, only this one's the opposite. So I'm going to be using sine. So sine of the 50-degree angle is y over the hypotenuse, opposite over hypotenuse. And I'll cross multiply, and that will equal 0.8 times sine 50. And I need to know how much of a distance that is. So what I'm going to do is I'm going to take 0.8 of cosine 50, and I'm going to add 0.8 times sine 50 and figure out that distance. Doing that all at once means I won't have to round in between. I can just put all of it in at once and hit enter. So that's 1.1270, etc. And it does say how much further would they have to drive. So I'm going to compare that to the 0.8. I'm going to subtract 0.8 to figure out how much further to the nearest tenth. Notice I haven't rounded yet. So I'm going to take that value that's already there. I'm going to hit minus 0.8 and see that it's about 0.3 miles longer. All right, I will see you in class.